Hello, I'm going to explain you the model of Lab 2 so you can get access to the video to review the points of this lab. As you can see, as you have read in the handout, we are going to have some more advanced modules, use them in our model like the seize, delay, and release module. And we are going to set a terminating condition for the simulation, use some more advanced variable and expressions, use the features for decide module, and give the priority to the queue. Our model, as you have read, is a call center that has the trunks as um, their line answering the calls from the customers. We are going to manage the details of the system, and I assume that you have read all of the details, and now I'm going to explain the complete model for you. If we look at the model, here, as you see, we start with the creation of the call arrivals. A normal create module, we call the entity type, we set the entity call as call, and we know that the arrival rate, the inter-arrival rate is a exponential distribution with this value. For now, forget about the entities per arrival. We will explain it at the end. What is the next step? The next step is to seize a trunk line, which is our resource. There are some details that I will go back to explain them. But here, if I want to seize the trunk line, instead of using the seize, delay, release in a process module, I'm going to use seize as a separate module that only takes care about seizing a resource. And I will explain you at the end why we do that. So if I add a seize module, it will let me to add a resource for it that you know that my resource going to be trunk line. So I put this name for that and continue. I know that the queue related to this seize would be the same name as the module. I called it seize trunk line. So the queue is called seize trunk line queue. One point is that it's mentioned that I have more than one trunk line. If we go through our data definition module for the resource part, we can see the list of resources that we have. So for the trunk line, I put the capacity value as 26, which is my number of resources that I have. That's the first thing that I should do. Then I'm going to take care about a rule. This rule says I want to continue if the number of available trunk lines are more than the number of occupied trunk lines. I'm going to make a decide module for that. So I open my decide module. I name it as if trunk line available or not. And the type is two-way by condition. There are two results based on the value of the condition, if the condition is true or false. What this condition says, it says that if the number of scheduled trunk lines, here the number of scheduled be greater than the number of occupied one. So it is mentioned in the handout that if you read through the variables instructions, you can see it. And also you can just use this expression. But how you can find it, it's again by right click and go to build expression. I go to build expression. I know that this is something about my resources. So it's about the usage. And it says my request is that the current number busy, you see that it has the abbreviation of NR. And what is the resource that I want to do this decision for it should be chosen is the trunk line. It should be less than the current number scheduled. So when I choose current number schedule, you see that it is using the abbreviation of MR. So I have this decision before continuing that says if there is any available trunk line, one of these 26, you can proceed. If not, you have to leave the system. The call have to be rejected. So first thing is this decide module. Then if it is true, the seize of the line will happen. If it is false, I'm going to make a simple record of how many calls are rejected. So it is a statistic definition of count type. And as you know, the value starts from 1 and will be increased as the number of rejected parts are increased. The name is the name that I put for it, a meaningful name, number of rejected calls. So this part is done. What happens here as I added an assign module at the beginning? It's for tracking the time of arrival, exactly like our first lab. So at the beginning, I add a assignment with attribute of T now that will register the arrival time of each call. So at the end, I can use it for calculating the cycle time or the total time that takes for a call to arrive and then finish the service and leave the system. Another record module I have used that is also simply to count the number of arrival calls. That is a counter, so it counts when an entity arrives and passes this module. So I have arrival, I assigned the T now, the time of arrival, the number of arrivals. I had this condition if the number of the available lines are more than the occupied ones. If yes, I continue and seize the trunk line. What happens next is that I will explain this assign module later, but simply what happens late is that I have a recording voice that has this uniform time, and you see that this time it's only delay because my trunk line is already seized, and now there is a delay time for this recording that explains them which number they should dial if they want to go for some further request. So what happens after this delay? There will be a decision. They will decide if they are going to have a technical support question or a sales information question or the order status inquiry. These three parts have three percentages. So I have a decide module based on not only two-way by chance, n-way by chance, more than two percentages. But as you see, I have 76 for the technical support, 16 for the sales information, and for the rest is 100 minus that. So I don't need to have the third value here. This is what will happen in the next next part of the call, but just make sure that what was this sign. This sign measure is very simple variable that has this job of counting the number of the calls that now are in the system. How it makes this call, this count based on having an initial name. It is the name that I create, and this initial name will be increased by 1 each time that an entity passes this assign measure. So question is why it is an attribute, but it is not an attribute, but it is a variable. Because it's a variable to count the total values of working process in my system. And I want it to be as a variable of the status of the number of works in process. And why it is work in process? Because this is the time that the work has started to be in my system. Before that, the process has not started yet. So why I want to calculate this number of work in process or calls that are in the system, because I have a condition for terminating my simulation. The terminating condition says there should not be any work in process. So I have to count how many working process I have to make sure that its value should be equal to 0 when I'm terminating my system. Continuing to the decide measure that I had, so I have now 3 divisions for continue. The first part is called technical support. What happens in my technical support? First, I have an assign measure. This assign measure is a very simple assign. I have the entity type that is assigned to this call. First, they were all calls. The entity type was call. This time, I want to change it to technical support call. So I want to change the entity to be sure that this is the entity that is in this process. Then I want to change the entity picture. So the type of the sign is entity picture, and the picture that I chosen was blue ball. Okay. And now, what is the next activity that happened is that I have a choice of product type that is also a choose by automatically chosen. So there is no resource for that, and there is a time for that. When the type of product is chosen, we know based on the question that there are 3 types of the product: 25%, product type 1, 34, type 2, and the rest is type 3. Each of them go through their own process. So the process for answering the questions about product 1, as you see, needs to have its resource that is that I called it product 1 agent. So it is easier to understand in the future what is the job of this resource. I know how much time it takes for this process. The same thing for product type 2. This time I have the resource of product type 2 agents and the time of processing this activity. The third time, the same thing. The third type, the same thing. So I have resource product type 3 agent. What what happens after I finish these processes? I had a resource here was agent for product one that was seized. The delay, the triangular 3, 6, 18 minutes happened, and now the agent is released. But which resource is not released yet is my trunk line. Each trunk line that is seized, all of this time was active, was still in use. But now this trunk line should be released. So now you see why instead of only using one process, I had to use seize, delay, release modules separately because some seize happens, but between this seize and this release, more than one activity happens. So now I have to release my trunk line, of course. I release it, and then I want to calculate the number of working process when I have one customer that leaves or one call that is ended. I know that this working process is now reduced because it is finished. Working process for me is any work that is not finished. When I'm at the end of the process, this call is finished, so I have the working process as finished. Now what's happened next? What happens next is I have to record two things. One is like our previous lab, the time interval between the arrival and finish of this call. So it is a statistic of time interval. I know that it's going to be the difference between finishing time, leaving the system, and the attribute that was called arrival time, which happened to be recorded at the beginning. And I call it the take call cycle time because it's the cycle time of take calls. Other counter that I have or other statistic that I have is a counter. It simply counts the number of completed take calls. So here I have finished my first process. My second process is about the sales information. So this call needs to have a salesperson to be answered. Like the previous one, I would add entity type of sales calls. I would add the picture that this time is a green bar. I would add a priority as well. Why I add a priority as an attribute is because I'm going to use it for the priority that is mentioned for the time that one resource of sales is going to answer a question for the group of order status inquiry. This one I will explain later. So here my process is to seize, delay, and release a resource of sales agent. And the time is given to me. I will finish it. Now I have to release the trunk line again because one trunk line was occupied for each of the calls that passed this process. I have to reduce the number of total working process as well. And I will record simply the cycle time for the calls that were sales call, and I will count the number of completed sales calls. And then it is finished. Here, I have the third group that are order status inquiry. I give a priority to this group. I give the entity type and picture specific for this one. This time it's an order status inquiry. It is a recorded information, so there is only delay. I don't seize another resource. The time is given to me. After that, there is a possibility that 15% of this group will need to ask a question from salespeople. So in that case, first I put a decide module. I would say 15% would go for the sales question that they have, and the rest should release their trunk line, reduce the number of work in process, have a calculation for the group that they had for their cycle time and for their number of orders completed, and leave the system. But what happens to that 15% that are going to use the same resource as the sales information? This time, this group would seize, but they have to seize the same resource as the resource that was used for the sales calls processes. So this is a sales agent. So I seize the same agent. I should be careful that I want the queue be also the same as the queue of sales call process. So I would add the sales call process queue here. There is one thing. They say that these people have the lower priority to be answered by the salespeople. Salespeople are occupied with the group of sales information. I already added a priority characteristic or attribute, which is 0 here and 1 here. So the only thing to make the model understand this priority is that I should go through the queue data module, and I look at the sales call process queue. As you see, my other queues are following the logic of first in, first out. But my sales call process queue should follow another logic. This logic is based on the value. It says choose the logic based on the lowest attribute value. And this attribute name is priority. So it says when the value of this priority is lower, there is a priority. So that's how I make my model understand what is the priority for this queue that is sharing with these two groups. My model should be considered finished, but there is one thing left, and that thing is about the logic of stopping the simulation. If you go to the run and look at the logic, you see that there is one logic, which means the time of the simulation should be finished. It is mentioned That's how much time it's this system working. So the system after 600 minutes should be terminated. But there is one point that also there must be no total work in process. As I already calculated my work in process, now I know that even if the time is exactly 600, the total working process should be 0. So the time will be modified. The terminating time would be modified based on the time is past, the total time of the system, which is 600 minutes, and also working process is 0. That's about terminating. I had one other condition that says there should not be any new calls be entered in the system. So the arrival should be stopped after the finishing time. What does it mean? It means that maybe I'm still in the system to manage working process after the time of 600. So my system is still working, but I should avoid any new arrival after this time. For that, I would say instead of number of entities per arrival, that is usually, for example, 1, and the max is infinite usually, this time I say at the beginning of the day until the end time of the system, use this variable instead. So I have to, first of all, create this variable and give it a value. So I have the variable of calls per arrival and a variable of max calls. I will create them in the variable data module. You see that I have max calls that has a very high number. I have the call per arrival that at the beginning has 1. So it says it has the value of 1 per arrival and a huge number as a maximum. That is like before, like if I didn't have these variables and I have only used number 1 and number of, for example, 10,000 or infinite as a max. But when the time is at 600, when it's the time that I don't want any other entity arise, I would have a dummy arrival to change this variable. This is called, the entity type is a logic entity. I want it to be arriving once and maximum once. So there is one entity that arrives at this time to do a change in my max calls variable and calls per arrival variable. It says at the time of 600, change the variable of max calls to 1. It means that there is no other calls, it is max 1. And the variable of calls per arrival equal to 0. It means that 0 arrival. So when this change happens to my variable is at the time of 600. What is the value of this variable? Usually before that time, it's for the max call, a huge number, for the call per arrival, 1. But it will be changed to call per arrival of 0 and max of 1 at the after the time of 600. So that's how I would avoid any new arriving after this time. So now in this model, we could practice how to have the logic for stopping arriving, how to have the logic of terminating based on the working process that should be 0, how we can give a condition to a decide module, how we can use the seize modules, delay and release separately, how we can use a priority to our queue. So that's all about this lab.